Hello, 5th grade, and welcome to week 34 of distance learning. Today we're going to be looking at Spiral Review 1.5 through 2.3. And again, the feedback I'm getting is that we like the longer videos so that you can watch the whole math and then sit down and do all your math in one day. So that's what we're going to do again this week. If you would like to go back to the old way of doing one lesson, one worksheet per video, just let me know. Send me a message. We can do it. Let's start with a little bit of review on long division, okay? Let's say I have 96 in the box and 6 outside. This would be the same thing as saying 96 divided by 6. Now if I'm doing 96 divided by 6, okay, what I need to do is I'm going to cover up the 6 and just ask myself, well, what's 6 divided by 9? Oh, I know 6 divided by 9 is 1. Now I do divide, multiply, subtract, and bring down. Divide, multiply, subtract, and bring down. 1 times 6 is 6. Divide, multiply, subtract. 9 subtract 6 is 3. Now I bring down. What do I bring down? Oh, the number I was hiding. Bring down the 6. 36. 36 divided by 6 is 6. 6 times 6. Well, I'm a monkey. I do tricks. 6 times 6 is 36. Do 36, subtract 36, you get 0. There's nothing left over. So what's your quotient? Your answer is 16. All right. There's a little bit of division review. Now let's take a look at some algebra. Ooh, okay. If I have 42 divided by n, wait a minute, Mr. Ivan, there's a letter in there mixed in with the numbers. That's right. I need to ask myself, what's 42 divided by n? And I'm going to tell you, it's like a secret code. I'm going to tell you that n equals 6. So what you do is you take the secret code, put 6 in for n, and do 42 divided by 6. And what do you get when you do 42 divided by 6? You don't even need to do long division for that one. 7. 42 divided by 6 gets me 7. Now what if I do the same thing, but a little bit harder? What if I say 25 divided by, in parentheses, and subtract 1? I'm still going to tell you that for today, n equals 6. Well, how do I solve it out? I put the number in the problem. 25 divided by, parentheses, 6 subtract 1. Okay? Now, there's something we need to do first, and that's what's in parentheses. Whenever you see parentheses, you have to do that part first. So what's 6 subtract 1? Well, 6 subtract 1 is 5. So we got to do 25 divided by 5. And what's 25 divided by 5? Oh, that's not too bad. 25 divided by 5 is 5. 5 is your answer. All right, nicely done. Now we're going to be working on, geometry, okay? So let's draw a little shape. I've got a little shape. And I'm going to say that this side is 6 feet, and this side is 9 feet. And I want you to find the perimeter. Perimeter. Now, here's the way you can think of perimeter. If we're pretending that this shape is my yard, the perimeter would be building a fence around my yard. So I need to know if one side of my yard is 6 feet and the other side is 9. And if it's a perfect rectangle, that means that this side is the same length as the one opposite. So this would be 9. And this side is the same as the one opposite. This would be 6. So now what I have to do is I have to add the sides together. So perimeter would be, ready, let's go through the sides together. 6 plus 9 plus 6 plus 9. Okay. Well, what's 6 plus 9? That's 15. What's 15? Oh wait, 6 by 9 again. That's also 15. So what's 15 plus 15? Ah, that gets me 30. All right, but here's the thing about perimeter. I need a label. What's the label? FT. That stands for feet. So the perimeter of my yard, if I'm going to build a fence, is 30 feet. So that means I got to buy 30 feet worth of fencing materials. That's perimeter. Well, what if I have something that's a little bit bigger, though? What if I have a shape that's 125 meters by 230 meters? Well, to find the perimeter, I'm going to follow the same procedure. I know this side is also 230, and this side is also 125. But because these numbers are bigger, let's write them off on the side so that we can stack them on top of one another. Okay? 230, 230 again, 125, 125 again. Add them together. 0 plus 0 plus 5 plus 5 is 10. Carry the 1. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 2 is 9. 9 plus 2 is 11. Carry the 1. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 1 is 6. 6 plus 1 is 7. Notice how I had to count up in my head a lot to get 710 meters. So if I was building a fence around this yard, I would need to get 710 meters worth of fencing supplies. All right. Now let's take a look at some fractions, okay? If I'm adding fractions, I might have the fraction 1/4 plus 1/4. And it's always helpful for me when I'm thinking about fractions to look at that rainbow fraction chart. I sent you a paper copy home back in the fall. If you need another one, let me know. And I remember that this part is a whole, and if it's broken into fourths, oh, here they are. So let's pull out our fourths. How many fourths do you have? You have 1/4. I have 2/4. Okay, so how many fourth pieces do I have? 2/4. Oh wait, what is that? 2/4. Notice how I didn't say 2/8. Okay, because if I had 2/8, well, let's look at our chart. Whoa, these are eighths. If I said 2/8, well, here's 2/8 pieces, and that's not even close to being equal to 2/4 pieces. So I know I don't change the denominator when I'm adding. However, now I'm going to do something called simplifying, and that means finding the shape that 2/4 equals, okay, let's see, thirds? No. Halves? Maybe. Yes, let's check. Yeah, 1/2 equals 2/4. So when I'm going to write it in simplest form, I'm going to say 2/4 equal 1/2. And I can see here, 1/2 equals 2/4. Pretty cool. All right, now let's look at, well, what if I have a whole number? Or what if I am subtracting, right? So what if I have 3/4 subtract 1/4? What am I going to get? Well, again, I'm going to pull out my rainbow fraction tiles, and I'm going to pull out 3 of the 4th pieces. There's a 4th, 1, 2, 3. Okay, I have 3/4, and now I'm going to take one of them away. How many do you have? Very good. You have 2 4th pieces. Notice you didn't say 2 over 0. You have 2 4th pieces left. I don't change the denominator. But I can say, remember, 2/4 equals what? 2/4 equals 1/2. That's what we just proved before. So for my answer, in simplest form, is I'm going to say 1/2. All right, well, what if I have some whole numbers mixed in with those fractions, okay? What if I have 5 wholes and 6/10 pieces, and I'm adding those to 3 wholes and 1/10 pieces? Here's what I do. I add up. Well, first I know I'm not changing those denominators, right? Because those denominators represent 10th pieces. So the denominator is going to stay the same. Now I add my numerator, the top number. 6 plus 1. 6 plus 1 gets me 7. All right. Now I add the whole number. 5 plus 3. 5 plus 3 gets me 8. So 8 wholes and 7 of the 10 pieces. All right. Well, what if I have a problem that looks like this? What if I have 8 subtract 4.5? I'm going to have to regroup, aren't I? I'm going to have to regroup. But what I'm going to do is I'm going to rewrite this problem, and I'm going to put 4.5 on the bottom. 4.5 on the bottom. Okay? Now when I do that, get rid of this guy. I just rewrote the problem. I need to regroup. Well, how many half pieces are in a whole? 1, 2. There's 2 half pieces in a whole. So when I borrow, it's going to look like this. 8 becomes a 7, and I'm borrowing 2 half pieces. So 2 over 2. Now I can go ahead and subtract. 2 halves, take away 1/2, you only have 1/2 left. Right? Let's look at it this way. 2 halves, take away 1/2, I have 1/2 left. All right, there we go. 7, take away 4 is 3. So you get 3.5 as your answer, as your difference. Very good. All right. Now let's take a look at decimals. Okay? We're going to be comparing decimals and fractions. Four tenths. That's how I read that. 4/10. 4/10. That's how I read that. 4/10. Did I just say the same number? 4/10. 4/10. Yes, I did. Since I just said the same number, we're going to say both these numbers are equal. All right. How about this one? Ready? 1 and 4/10. 1 and 4/10. Okay. 1 and 3/10. 1 and 4/10. 1 and 3 tenths. Are those equal? No, they're not equal. You can tell that. Which one's bigger? Listen to me say it again. 1 and 4 tenths. 1 and 3 tenths. I think you can tell that 4 tenths is bigger than 3 tenths. So the number alligator, who's living in the swamp, he sneaks up on numbers and he starts to chomp. And he chomps a bigger number. All right, let's do one more. Ready? $56 hundredths. 56 hundredths. 9 hundredths. 9 hundredths. You can think of decimals like money. 56 cents. 9 cents. Ah, okay, now I can see this one is obviously the bigger one. Nicely done. All right, let's move on. If we're thinking about decimals like money, then we can also think about decimals when I'm adding like money. If I have $7.07 and you gave me $3.65, how much money would you have? Well, what I'm going to do is I'm actually going to rewrite this problem. And I'm going to line it up on the decimal point. So I'm going to put my addition sign, equal bar, decimal point. And now move this $3.65 over there. Okay? All right. Now I'm going to bring down the decimal point to my answer. $7.07 plus $3.65. The decimal point is important because $707 is way different than $7.07. All right, now we just start doing our addition. 7 plus 5 is 12. Carry the 1. 1 plus 0 plus 6 is 7. 7 plus 3 is 10. No need to carry the 1. $10.72. If I forgot to put that decimal point there, I'd have 1,072, which is way different than $10.72. Okay? Now what we're going to do is think about rounding decimals to the whole number. So, if you have $6.70, should you round up to $7 or down to $6? Remember the rule of the magic 5. You're going to round up. So this becomes 7 wholes. But what if it was $6.07? You're actually going to round down to $6 on this one. Why? Because of this 0. 0 is right before the 6, which is smaller than 5. Even though they both have a 0 and a 7, there's a big difference between 70 cents and 7 cents. So I round down to 6. Let's practice rounding one more time. If I have $12.10, hey, the 1 is smaller than 5, so I round down to $12. If I have $12.01, I still round down to 12 because that 0 there is telling me I'm rounding down. The nearest dollar is 12. Okay, now I'm going to give you a list of numbers, okay? And let's say I gave you the number 3, 4, 4, 4, 6, 9, all right? 3, 4, 4, 4, 6, 9. Now what I want you to tell me, I want you to tell me 4 different things. The range, the mode, the median, the mean, and I want you to tell me one more thing, the outlier. Let's pretend that this is a set of data, okay? And let's pretend that we're measuring how tall sunflowers are in the garden. One is 3 feet tall, one's 4 feet tall, 2 more are also 4 feet tall, one is 6 feet tall, and one of them is 9 feet tall. Whoa! Well, what's the range of the measures of these sunflowers in the garden? The range means what's the difference between the smallest number and the biggest? 3 and 9, what's the difference between those two? Hey, you got it. The difference between those two numbers is 6. So that means in my sunflowers in the garden, there is 6 feet difference between the shortest sunflower and the tallest sunflower. Okay? Now my mode is the number that occurs most often. Which number occurs most often? That's pretty easy to see. 3 of the sunflowers are 4 feet tall. So the mode is 4. My median is, when I put them from least to greatest, which number's in the middle? Okay, 3 and 9, 4 and 6, 4 and 4. 4 is in the middle. Okay. And my mean is another way of thinking average, and I'm actually going to write average. My average height of sunflowers. This one's probably the most helpful. What I do is I add all these numbers and then divide it by how many sunflowers I have. So let's add all these numbers together. And then we're going to put it in the division bar over here in our work area. Okay? 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15. 15 plus 6 is 21. 21 plus 9 is 30. So if I took all the sunflowers, add them together, I'd get 30. Now what I need to do is divide by how many sunflowers do I have? 1, 2, 3, 4, 5, 6. There's 6 sunflowers. So 30 divided by 6, oh, you know that one. It's 5. So my average is 5 feet. However, we know that 3 of those are 4 feet tall. So now we're going to look at something called the outlier. The outlier means one of them is much taller than the other ones. Which one of these is much taller than the others? Or much shorter? Well, there's only 1 foot of difference here. There's 3 feet of difference here. There's 4 feet of difference, or 5 feet of difference between those. So that means the one that's 9 feet tall is the super sunflower. And we're going to call it the outlier because that one is bringing my average up. And I might think, oh yeah, average height of 5, even though most of my sunflowers, 1, 2, 3, 4 of them, are actually shorter than 5 feet, while only 2 of them are higher. Because this one is so much higher, it's bringing that up. All right, now what we're going to do is we're going to take one more look at geometry, okay? And today we're just going to be reviewing some basic shapes names, all right? So play along with me. What's this shape? Triangle, good. What's this shape? Pentagon, 1, 2, 3, 4, 5 sides, pentagon. What's this shape? That one's easy, that's a square. What's this shape? Kind of looks like a triangle with its head cut off. That is a trapezoid, trapezoid. Right. How about this shape? You might say stop sign. How many sides? 1, 2, 3, 4, 5, 6, 7, 8. While an octopus has 8 legs, so an 8-sided shape is an octagon. All right. You may look at this and you may say, diamond, but it's not actually a diamond. It's called a parallelogram because I have two parallel lines. Parallelogram. Similar to the parallelogram, rectangle. That one's easy. Finally, one more. This one's pretty hard. Let's count up how many sides. 1, 2, 3, 4, 5, 6. A six-sided shape is called a hexagon. Okay? Go ask your mom or dad to find you a hex key and count in a hex key. In fact, I might have one on my desk here. I do! Lucky me. This is a hex key. Look very carefully. How many sides are on that end? Maybe this end would be easier to see. 6! Hexagon. That's why we call it a hex key.
Hey, Matt, you do have a UPS package in the copy room.
All right, 5th grade. As you see, I've got to go get my package. God bless you on your study of math today. Please reach out to me in our Zoom calls every Tuesday and Thursday at 2 o'clock if you got any questions.